Hey everyone, let's knock out the problem that we started in class, but I let you finish. Given y equals the quantity 4x plus 2 squared, find dy over dx. Now we wrote the limit definition of dy over dx out, but let's dig in. There's no easy way to take this limit other than to just do a bunch of foiling. So I'm going to FOIL this first part in brackets. It's going to be 16 x plus h quantity squared plus, don't forget this middle term right here, 16x plus h, right? That's the OI part of the foiling, plus 4, right? That's what you get from foiling the part inside the brackets, right? Then we're going to FOIL the part inside the parentheses, and that's somewhat similar. Minus 16x it's plus 16x plus 4, right? We're adding stuff. So in parentheses, all over h. Now, sadly, we need to, the only way to keep going here is to FOIL the x plus h squared, distribute the 16x plus h, right? And we're going to get, actually, when you do it all out, I'll just sort of write the simplified version, 16x squared plus 32xh plus 16h squared. Then you're going to get 16x plus 16, what I said, 16x plus 16h, and then plus 4, right? That's all the stuff you get in the brackets. And then let's just say minus 16x squared minus 16x minus 4 when you distribute that negative sign. So now you might notice a couple of things cancel pretty nicely. And I don't know, use green here or something. All those things cancel really nicely. Okay. So we're left with the limit as h approaches 0 of, and I'm going to factor an h out. So we get h times 32x plus 16h plus 16. All over h. Whoop. And you might notice that those h's cancel out, and then when you take the limit, you get 32x plus, all right, whoopsies, sorry, one sec, we have a plus, plus 16h, sorry about that, plus, that's not plus 16h, plus 16 times 0, plus 16, and then that leads us to 32x plus 16, our final answer. Okay. Now, I did say I would do another problem, so let's maybe get one of those going. Let's find the derivative of, we'll say g of x equals, I don't know, let's consider 4x cubed minus 6x plus 5. Okay? Let's just find the derivative of that. It's a little bit involved because of that cube, but we'll be okay. All right, so dy over dx is going to equal the limit as h approaches 0 of 4x plus h quantity cubed minus 6 quantity x plus h plus 5 minus the quantity 4x cubed minus 6x plus 5 all over h. Again, because it's polynomial stuff, no real nice way to do this other than just to multiply it all out. And I'll just tell you what you get. When you do x plus h cubed, it winds up being x cubed plus 3x squared h plus 3xh squared plus h cubed. That's using Pascal's triangle, or, really more formally, binomial coefficients. Anyway, we have minus 6x minus 6h minus 4x cubed plus 6x minus 5 all over h. Let's do a little more distributing here, and then we'll see that some stuff cancels nicely. We're going to get 4x cubed plus 12x squared h plus 12xh squared plus 4h cubed minus 6x minus 6h minus 4x cubed plus 6x minus 5. All over h. Right, so we get that. Oh, wait, hold on a sec, sorry. Way up here, I think I forgot something. That should have been a plus 5 right there. Right here, this should have been a plus 5 right there. And this right here should be a plus 5 right there, right? Because all the constants should always cancel out. All of the non-h terms should cancel out. Right, so for example, the negative 6x with the positive 6x, plus 5 with the minus 5. Sorry for that error earlier on. And then we pull an h out of what we've got. On top, we've got h times 12x cubed plus 12xh plus 4h squared minus 6 all over h. And of course, we see that those h's cancel out nicely, and we are left with 12x cubed plus 0 plus 0 minus 6, or 12x cubed minus 6. That's what we've got. Thanks for playing.